This is the second of 3 or 4 videos having to do with factoring and factoring trinomials. In this video, we look at factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1. And remember that to factor a trinomial means, can you write it a sum or difference of terms as a product of factors. So that is the aim whenever you see to factor, right? Can you rewrite a sum or difference of terms as a product? So that is our goal here. All right, now let's look at some practice problems. And remember, to factor these trinomials, we are going to apply the AC method, if possible. So the question is typically factor each trinomial completely if possible, right? So the first thing we need to do is to ask, we go through a certain thought process, which is, is there a GCF? Whenever you're asked to factor, you want to ask this question: is there a GCF? GCF means greatest common factor. In other words, is there some number or letter that's common in each term? Right? So there's no number that's common in each of these 3 terms. So no, there's no GCF. Next, we ask, what is the number of terms that we have? Depending on the number of terms will determine which factoring technique we would use. And in this case, we got 3 terms. So when there's 3 terms, we should try the AC method. All right, AC method says to look at the coefficient of the leading term and to look at the constant term and multiply these and then ask, are there any 2 numbers that multiply to give AC or 18 and that also add up to the middle coefficient or the coefficient on X, which is 11 in this case? All right, so we can see that 9 and 2 does work. 6 and 3 does not work because 6 plus 3 does not add up to 11. So 9 and 2 definitely does work. It satisfies the condition. It multiplies to give 18, and those 2 numbers also add up to give 11. So then we would rewrite the first term, rewrite the last term, and then replace the middle term by these 2 factors and include the variable on them. So 9x plus 2x plus 6. Next, we're going to go ahead and factor from the first 2 and factor from the second 2 terms. So ask, what can factor from the first 2 terms? Is there something in common in both of those terms? Or what is the GCF of both of those terms? And we can see that the GCF is 3x. After we take 3x out of these first 2 terms, what would be left then? To get so that when we multiply, we get back to 3x squared plus 9x. So you could see that in order for us to get 3x squared, we're going to need an x here. Right? Now, in order for us to get 9x, we're going to need to multiply 3x by what? 3. right? So we factor the first two. And next, let's go ahead and factor the second two. Is there anything common between 2x and 6? And we can see that 2 is common. Now, when you take 2 out, what would be left then to get back to 2x plus 6? Well, we're going to need an x, and we're going to need a 3. Now, if you multiply 2x, you get 2x. If you multiply 2 times 3, you get 6. So that is a confirmation that this is the correct factorization. And now we see that we have two of the same factors here, x plus 3 here and x plus 3 here. This means that x plus 3 can be factored out of those two terms. Now, when we factor x plus 3 out of this first term, we're going to have left 3x. When we factor x plus 3 out of this second term, we're going to have left plus 2. And that is our final answer. So this thing factors to this. All right? And we do the same technique for each of these questions. All right? Let's do number 2 now. Here again, we're going to go through the same thought process, which is there a GCF? No. What is the number of terms? 3. Okay, so try AC. It doesn't always work, but most of the time it can work. All right, so that means multiply 6 times -7. And this is giving us a -42. So we ask, are there any two numbers that multiply to give -42 and add up to 11, positive 11? And we can see that 7 times 6, or 7 times -6, will multiply to give -42. But it will not add up to 11. Those two numbers give a positive 1 when added. So this will not work. And 42 and 1 will not work. Okay, 14 times -3 will work. Right, 14 and -3 will work. It'll multiply to give -42, and these two numbers will add up to give positive 11. So since they work, we go ahead and rewrite the first term, rewrite the last term, replace the middle term by the two factors that we found to work or to satisfy the condition. So we're going to go ahead and put 14y here, -3y here. And it doesn't matter the order in which you write these. In other words, you could put 3y first and positive 14y second here. It'll still work out when you factor. Right, so next I'm going to factor these two and factor these two. When I factor from these two, I'm asking, is there anything common in both of those terms? And there is, and that is 2 and y. And when I take 2y out, how can I multiply to get back to 6y squared? I'm going to need to have a 3 and a y. Right? Now, how can I multiply to get 14y? I'm going to need a 7. Right? So that completes the first two factors or two terms. And next we look at these two. We're going to need to factor out. Let's try -1. If we factor out a -1, what would be left then? 3y plus 7. And you can see that when we multiply -1 throughout the parentheses here, we are going to get back to -3y minus 7. Now, this is good because these two factors here are the same, and that is really what we want, what we're looking for. All right, now since those two factors are the same, we go ahead and factor out those common factors, leaving us a final answer. This is our final answer. All right, moving on to number 3. All right, this time we've got 3 terms. This time we go through our same thought process. Is there a GCF? In this case, we do have a GCF. And what is the number of terms? 3. So we're going to try the AC method after we first take out that GCF. Right, so that GCF is going to be, we're looking at a number that's common in all 3 terms here. So that number is 3. 3 is common in all 3 terms here. So we're going to have, after we take 3 out, we'll have 2z squared minus 13z minus 7. All right, and next, after we've taken out that GCF, we want to go ahead and try to factor this off to the side somewhere. So let's go ahead and factor this. This will give us, we're applying the AC method here. So that's 2 times negative 7, which is negative 14. And we want to know, are there any 2 numbers that multiply to give negative 14 and add up to give negative 13? And 7 times 2, or 7 times negative 2, will give negative 14. But 7 plus negative 2, or 7 minus 2, will not add up to negative 13. So that factorization will not work. Let's try, how about negative 14 and positive 1. Negative 14 times positive 1 will give us a negative 14, and it will add up to negative 13. So this is the correct values that satisfy our AC method condition. So then this, we can go ahead and factor. We rewrite the first term and rewrite the last term and just replace the middle by the 2 factors that we found. So negative 14z plus 1z. Right, and next I'm going to go ahead and factor the first 2 terms and the second 2 terms. What can come out of the first 2 terms? 2z, leaving us z minus 7. What can factor out of the second 2 terms is a plus 1, leaving us z minus 7. And we got the same z minus 7 in both of those terms, so we can go ahead and factor that out. So z minus 7, and after factoring that out, we'll have left 2z plus 1. And so this factors completes the factorization of 2z minus 13z minus 7, but this is not the final answer. We still have to include the 3 in front here. So our final answer to this is going to be 3z minus 7, 2z plus 1. Righty, so number 4 now. Let's look at this one. This time, same thing. What is our thought process? Is there a GCF? In this case, no. What is the number of terms? 3. So when there's 3 terms, we want to try the AC method. All right, now with this one, you see that we have some big numbers here. Even in this earlier case, we were dealing with some big numbers here. Like 7 times negative 30. This is going to give us negative 210. So the question is, are there any two numbers that multiply to give negative 210? And it also will add up to positive 29. Now this may take a while to figure out how to come up with these numbers if there are any two numbers. So what we can do is bring up our handy calculator, and there's a quick way to determine the factorization. And that is, if you have a graphing calculator, like this TI calculator, you can type in, there we go. All right, so we're going to go y equals, and we're going to type in our negative 210, and then press divide, and we're going to click on X, right? And then we're going to go to second graph. And you can see that all of the factors here of negative 210. So 1 times negative 210 gives 210. 2 times negative 105 gives 210. 3 times negative 70 gives 210, negative 210, and so on. Now, this decimal number here, whenever we have a decimal, that means that it could not be divided evenly. So these two would not be considered factors of 210. All right, so we're looking for some two numbers that would add up to 29. So it looks like 6 and negative 35 can do it if we change the 6 to be a negative and the 35 to be a positive. So we can say 35 minus 6. Right, so this satisfies the condition. And so then we're going to go ahead and rewrite the first, rewrite the last, replace the middle, right? Then factor from the first two, factor from the second two terms. We're going to have 7k that can come out of the first two, leaving us k plus 5. Minus 6 can factor out of the last two, leaving us k plus 5. K plus 5 in both terms, giving us k plus 5 times 7k minus 6. And this is our final answer, right? So this thing factors as this. All right, moving on to number 5. Here again, is there a GCF? No. Number of terms, 3. Try AC. Because if there's not 3 terms, we wouldn't want to use the AC method. We can't. All right, so then we're going to 5 times negative 49 is going to give us, see, this is like negative 245. So again, we're getting big numbers here. So we're asking, are there any two numbers that multiply to give negative 245 and then add up to 28? And again, the calculator comes in handy here. This time y equals and negative 245 divided by x, and then we go to second table or graph, and it gives us all of the factors of negative 245, and we need the one that adds up to 28. The two that add up to 28 are, I think it's negative 35 and 7. Yes, changing the signs. So negative 7 and positive 35 add up to 28. All right, so we're going to rewrite the first term. Now here, when we have two variables, the only difference in factoring with these two is that when we replace the middle term, we're going to use both variables. So we're going to have here, plus 35xy and minus 7xy. And of course, the last term had a y squared in it. So just be cautious or careful. Let's include both variables, and then again, factor from the first two, factor from the second two terms. What can come out of the first two terms here is 5x, leaving us x plus 7y. What can come out of the second two terms here? Looks like 7 or negative 7y, leaving us x plus 7y. All right, now these two are the same. So we know we're doing things properly, and therefore x plus 7y can come out of those two terms, leaving us 5x minus 7y, which is our final factorization. All right, moving on to the last question here. This time, same thought process. What is a GCF? None. Number of terms? 3. So try AC. Right, AC says 2 times 3 is 6. Are there any two numbers that multiply to give 6 and that add up to give the middle coefficient, which is negative 1? Let's see, 2 times 3, 6 times 1. It doesn't seem like there's anything that will work. So this won't work here. Negative 2 and 3 gives positive 6, but it will not add up to negative 1. So no, none. So therefore we say this cannot be factored. And so it's said to be prime when it cannot be factored. All right, that's it. I hope that you found this video to be helpful. Like and subscribe. This was part of the math of numbers and symbols, but math is order. It's not just about numbers and symbols.